afternoon friends, I welcome you all in this session. As you are aware, in previous session we did work out couple of examples on sampling and sampling distribution, and we have seen how we calculated probabilities within given range of x values. And in one of the examples we have also found out the value of z where the probabilities were given. In today's session we will work out couple of exercises. Now, this particular exercise will help you in understanding the concepts of sampling and sampling distribution. So, these are couple of statements and you have to tell me whether these statements are true or false. So, let us begin with first statement. When the items included in a sample are based on the judgment of the individual conducting the sample is said to be non-random. Now, there is an individual person who is choosing samples from a population. So, what it would be? Would it be random or non-random? It will not be random. So, this statement is true, it is said to be non-random, right. A statistics is characteristics of a population, is it so? We have seen characteristics of population as well as characteristics of sample. So, what is this? Statistic is what? Is about population or sample? So, this statement is false, because statistic is a characteristics of sample, not population. What is the characteristic of population? It is called parameter, right, not the statistic. Let us look at third one. A sampling plan that selects members from a population at uniform intervals either in time, order or specific or space is called stratified sampling. Is it so? First of all, you should know that whether this is random or random sampling or non-random sampling. In other words, whether this one is a probabilistic sampling or non-probabilistic sampling. So, we know that stratified random sampling is probabilistic one, but in probabilistic sampling we do not select items from population on the basis of these things, right. So, this statement is actually a false one, right. By the way, what that sampling is called if not stratified? That is known as systematic sampling, right. Of course, systematic sampling is again a probabilistic sampling. Let us look at fourth one. As a general rule, it is not necessary to include a finite population multiplier in computation of standard error of the mean when size of the sample is greater than 50. Is it correct? In fact, I did not cover much about population finite multiplier, but it is used when your sample fraction is more than 0.05. Sample fraction is nothing but the ratio of sample size to population. Okay, so, we can skip this, but this statement is false one. Let us look at the next one. The probability distribution of all possible means of sample is known as sample distribution of the mean. Is correct or incorrect? The probability distribution of all the possible means of samples is known as sample distribution of the mean. Yes, this is true, right. Let us look at the next one. The principles of simple random sampling are the theoretical foundations of statistical inference. Is it true? Yes, this one is true, because on the basis of sample itself we infer about population. Let us look at seventh one. The standard error of the mean is the standard deviation of the distribution of sample mean. Is it correct? the standard error of mean is the standard deviation of the distribution of sample means. Yes, this is true, right. Let us look at next slide. Statement number 8. A sampling plan that divides the population into well defined groups from which random samples are drawn is known as cluster sample or cluster sampling. Is it true or false? We have seen that this is a type of probabilistic sampling, right, and in cluster sampling and in stratified sampling, in both these samplings we first divide, we first make different subgroups or strata, right, and then from each of depending upon which method we have to apply, we select samples from each of these groups or strata, right. So, this is not cluster sampling. So, this statement is false. A sampling plan that divides the population into well defined groups from which random samples are drawn is known as cluster sampling. No, this is known as in fact stratified sampling, right. Let us look at 9th one. With increase in sample size, the sampling distribution of the mean approaches normality regardless of the distribution of the population. This is true, right, and this is what we have seen, and this is one of the properties of sampling central limit theorem, that whatever is the shape of the population distribution, the shape of the sampling distribution will be approaching normal when we increase sample size. The standard error of the mean decreases in direct proportion to the sample size. Is it correct? The standard error of mean, this standard error of mean, right, this what, this divided by under root. So, it is not directly proportion to the sample size, it is inversely and this under root of n. Okay. So, this statement is false, right. To perform a complete enumeration, one would need to examine every item in a population. Is it correct? Yes, this one is correct. This one is true, right. If we do not evaluate every item, then it becomes, if we take few of them, then it becomes sampling. In everyday life, we see many examples of infinite populations of physical objects. True or false? Do we see infinite populations of physical objects? Can we not count them? Yes, we can count them. So, we see finite. So, this is false. Let us look at the next one. To obtain a theoretical sampling distribution, we consider all the samples of given size. Is this correct? To obtain a theoretical sampling distribution, we consider all the samples of a given size. Yes, this is true. Okay. Let us look at next one. Large samples are always a good idea because they decrease the standard error. Would it be right to say so? No, there is a false statement, right, not a correct one. Okay. This is not the reason why we take large sample, because it decreases the standard error. We take large sample, of course, large sample size minimizes standard error, but that is not the reason for taking large samples. So, this one is false. Let us look at the next one. If the mean for a certain population were 15, it is likely that most of the samples we could take from the population would have mean of 15. So, let us say this is a population with mean 15, right. If we take few samples, then would you be getting sample means as 15? No, it is not correct, it is false. You will have for 1 or 2 samples it is possible, but it is not possible for all of them, right. This mean would be varying. Look at 16th one. The precision of a sample is determined by the number of items in the sample and not the proportion of the total population that is sampled. The precision of the sample is determined by the number of items in the sample and not the proportion of the total population that is sampled. Yes, this one is correct. So, 16 number is correct one. Let us look at 17th. The standard error of a sample statistic is the standard deviation of its sampling distribution. Is this correct? The standard error of sample statistic is the standard deviation of its sampling distribution. So, this is correct. This one is true statement. Let us look at the 18th one. Judgment sampling has the disadvantage that it may lose some representativeness of sample. Is this correct? Do you think so? Judgment sampling has the disadvantage that it may lose some representativeness of sample. Yes, that is why this is not a good method of sampling. This is a non-probabilistic sampling method, judgmental sampling, right. Let us look at the 19th one. The sampling fraction compares the size of the sample to the size of the population. The sampling fraction compares size of the sample small n to the size of the population capital N. Yes, this is correct. This is sampling fraction, right. Any sampling distribution can be totally described by its mean and standard deviation. Is it possible? Any sampling distribution, though we did describe couple of distributions by its mean and standard deviation, but it is not necessary that any sampling distribution can be totally described by mean and standard deviation. So, this is false. Though had it been like this many, then this statement would have become true. 21st, the precision with which the sample mean can be used to estimate the population mean decreases as the standard error increases. The precision with which the sample mean can be used to estimate the population mean decreases, it means precision decreases as the standard error increases. Yes, this is true. Of course, when there is more error, how precision would increase? Precision would 100% decrease, right. It will always decrease. Which of the following is a method of selecting samples from a population? Let us look at these methods. So, do we select sample from population using judgmental sampling? Yes, we do. Random sampling? Yes, we do this. Probability sampling? Yes. So, we will say that in fact random sampling is nothing but a type of probability sampling, is not it? And of course, judgmental sampling is non-probabilistic sampling. So, all of this ABCD, ABC, A and B, but not C, no, this is there in the answer. So, right answer is D, all of these, right. Let us look at this one. Choose the pair of symbols that best complete this sentence, and sentence is dash is a parameter whereas dash is a statistic. Parameter is always about population and statistic is about sample. So, of course, so this is sample size, sorry, population size and this population mean. So, we have to write here some parameter and here statistic, right. So, these two are both are about population, right. What about this capital N and small n? No, small n is not actually statistic, it is sample size, right. All of this, let us look at second first. This is population standard deviation and this is sample standard deviation. B and C, but not A, no. So, the right answer is B. So, standard deviation and standard deviation of sample, right, standard deviation of population and standard deviation of sample, right. So, answer B is correct. In random sampling, when we describe mathematically how the objective our estimates are, why is this? Let me read it once again. In random sampling, we can describe mathematically how objective our estimates are. Why is this? We always know the chance that any population element will be included in the sample, any, right, just focus on this, right. Second, every sample always has an equal chance of being selected. All the samples are of exactly the same size and can be counted. None of this A and B, but not C. In random sampling, we can describe mathematically how objective our estimates are. So, why? What are the reasons for that? If you look at this 24th, then E is correct. So, every sample always has an equal chance of being selected. This is there, right. This is one of the basic feature of probabilistic sampling, right. And second is, we always know the chance that any population element will be included in the sample, right. So, we know these two things, that is why we always say that the random sampling, our objective estimates would be objectively correct, right. Let us look at 25th. Suppose you are performing stratified sampling on a particular population and have divided into strata of different sizes. Now, how can you now make your sample selection? So, you have got different strata, let us say this one, right. Now, how to select elements from each one of these strata? Select at random an equal number of elements from each strata. Should we go for equal number of elements from each one of them? Draw equal number of elements from each stratum and weigh the result. First of all, select at random an equal number of elements. Draw equal number of elements from each strata and weigh the result. Draw numbers of elements from each stratum proportional to their weights in the population. So, this is there in the answer C. So, C is here in part E, it means B is also correct, right. So, draw equal number of elements from each strata and weigh the results. Not necessarily of course, there is nothing wrong in selecting those data, those elements randomly, but we have to have equal number of elements from each stratum. Let us look at this just once again. Keep in mind, draw equal number of elements from each stratum. This is an important point you should remember. Okay. Let us look at 26th. In which of the following situations would this be the correct formula to use for computing population standard error? Sampling is from an infinite population, sampling is from a finite population with replacement, sampling is from a finite population without replacement, A and B only, it means this and this, and B and C only, it means these two. So, for 26th, option D is correct, which is A and B. So, sampling is from an infinite population or from finite population with replacement would give you a condition wherein this formula would be appropriate to apply. Let us look at 27th. The dispersion among sample mean is less than the dispersion among the sampled items themselves, because the dispersion among sample mean is less than the dispersion among the sampled items themselves, because each sample is smaller than the population from which it is drawn. Very large values are averaged down and very small values are averaged up. The sampled items are all drawn from the sample from same population, none of these, and B and C, but not A. So, these two are the correct options. It means answer E is correct. So, very large values have averaged down and very small values are averaged up, and the sampled items are all drawn from same population. That is why this statement is like this. Okay. Let us look at 28th. Suppose that a population with size 144 and has got mean 24. What is the mean of the sampling distribution of the mean for sample of size 25? Sample of size 25. So, in fact, the answer would be 24, it will remain as it is, right. What is the mean of the sampling distribution of the mean for samples of size 25? Because this sample size affects this, is not it, not the mean. Okay. The central limit theorem assures us that the assumption distribution, that sampling distribution of the mean is always normal, for large sample sizes, approaches normality as sample size increases, appears normally when n is greater than 1000. So, this is not correct. Is always normal? No, actually it depends on sample size. So, for 29th, option C is correct, as approaches normality as sample size increases, right. Okay. So, in fact in one of the classes we have seen that our, let us say this was a skewed distribution, right, let us say population distribution, and when we increase sample size, let us say this is the distribution or sampling distribution with n is equal to, let us say 5 or let us say 25, but if we take n is equal to 100, then the same it would become exactly normal, right. Let us look at 30th number statement. Suppose that for a certain population, this is calculated as 20, when sample of size 25 are taken, and as 10 when sample size of 100 are taken. So, this value, the population standard error, is 20 when sample size is 25 and it is 10 when sample size is 100, right. A quadrupling of sample size, right, we have just increased sample size by 4 times, right. It was 25, now it is 100. Then half of this, we can conclude that increasing sample size is always cost effective, sometimes cost effective, near. So, it is, these two are extreme answers. So, the final one is this one, right, sometimes cost effective for question number 38. Let us look at 31st one. Refer again to the data in question 30th. What must be the value of sigma for this infinite population? So, the answer would be 100. What must be the value of sigma for this infinite population, and the answer would be 100. Okay. Let us look at 32nd. The infinite population multiplier does not have to be used when the sampling fraction is greater than 0.05, greater than 0.5, less than 0.5, greater than 0.9. So, answer is none of these, because it has to be less than 0.05. Had it been less than 0.05, then we would have chosen this option, but for the time being, for this statement, this is the answer, right, none of these. The standard error of the mean for a sample size of 2 or more is always greater than the standard deviation of the population, generally greater than the standard deviation of the population, usually less than standard deviation of population, none of these. What it would be? The standard error of the mean of a sample size of 2 or more is always greater than the standard deviation of population, generally no, it is D, none of these, right, because we have seen in sampling distribution that the mean of population distribution and mean of sampling distribution are same, but the standard deviation of the, and we do not call it standard deviation. So, far as sampling distribution is concerned, we call it standard error, right, but the standard error will always be less than population standard deviation by this formula, is not it. A border patrol checkpoint that stops every passenger when is using what? It is simple random sampling, systematic sampling, stratified sampling, or complete enumeration. Just read this carefully. A border patrol checkpoint that stops every passenger. It means there is nothing like sampling, right. So, answer is D, it is complete enumeration. In a normally distributed population, the sampling distribution of the mean is what? In a normally distributed population, the sampling distribution of mean is normally distributed, has a mean equal to the population mean, yes, this is true, has a standard deviation equal to the population standard deviation divided by square root of sample size? Yes, this is also true. So, what is the wrong answer? What is the correct answer? All of the above, both A and B. Answer is all of the above, right. All these 3 points are correct, because it is always normally distributed. Of course, we always say that as sample size increases, it becomes normal, right. Let us look at this slide. The central limit theorem. The central limit theorem requires some knowledge of the frequency distribution, permits us to use sample statistics to make inferences about population parameter, relates the shape of the sampling distribution of the mean to the mean of the sample, requires a sample to contain fewer than 30 observation. What is the correct answer? Central limit theorem actually permits us to use sample statistic to make inference about population parameter. For example, with sample mean we will calculate population mean. Let us look at this. A portion of the elements in a population chosen for direct examination or measurement is what? What it is called? A portion of the element in a population chosen for direct examination or measurement is called sample, is not it? Sample. The proportion of the population contained in a sample is what? The proportion of population contained in sample is sample fraction, is not it? This is what we have seen, or sampling fraction. So, this is the one, right. 39th is the process by which inferences about a population are made from information about a sample. So, statistical inference is the process by which inferences about population are made from information about sample. So, this is statistical inference. 40th, the dash is the distribution obtained by finding the sampling distribution of all samples of a given size. Which the theoretical sampling distribution, right, or sampling distribution simply. Dash sampling should be used when each group considered has small variation within itself, but varies a wide variation between different groups. Just see. Which sampling should be used when each group considered has small variation within itself, but there is a wide variation between groups. So, this is stratified random sampling. 41, right, because let us say there are two groups of, let us say, boys and girls, right. So, these two are different groups, right. However, in this group boys and girls there is little variation amongst themselves, right. A method of random sampling in which elements are selected from the population at uniform interval is called systematic, right. Either uniform interval or let us say after some number of units, or after some specific time and so on, right. So, either time or let us say some number or any logic should be there before selecting samples, right. So, that would be called systematic one. 43rd is the degree of accuracy with which the samples mean can estimate the population mean. So, this is the precision. Precision is the degree of accuracy with which the sample mean can estimate the population mean, right. Within a population, groups that are similar to each other, although the groups themselves have wide internal variation, are called clusters. There is wide internal variation, right. So, you will have, let us say, a group of, let us say, this one cluster, second cluster. So, in this cluster you will have, let us say, if you are finding mean height of students studying in an educational institute. So, all students are here, right from first year to final year, PhD and so on. So, all of them are, let us say, sitting in a canteen, right. So, this is called a cluster, right. Let us say many of them, again one more cluster, they are there in a bank, right. So, there is wide internal variation, right, because you will have final year students as well as first year students, right. A sampling distribution of the proportion is a probability distribution of the sample proportion, right. So, with this, let me finish this session. In next session we will start some of the concepts related with estimation. Thank you very much.